more time for anybody. I am very pleased to introduce Dr. Emil Svoboda. Like I said, this man has passion, and I don't know where he gets the time because he is a busy man. And, you know, like we have, if you guys have been receiving, the dentists do, the technicians, some of them don't. And we have some technicians that participate. We publish Spectrum implants. And Dr. Arlen has been mentoring an idea like the big questions where people can send in and can ask any questions on implants. And now, you know, like Murray wants to step a little bit back. And of course, you know, like we knew where to go. Emil Svoboda was going to step in and take over that spot. So, you know, like if you have any questions, just send them to his to his email. Okay, not only on the reverse margin, but on other, you know, like on other implant situations. Emil is a graduate of the University of Toronto. He's one of the few doctors in Canada with PhDs. Okay, so he's a doctor. Okay, he's a fellow of the AGD, an honor fellow of the AAID. He's a diplomat of the ABOI and ID. He has received the Award of Merit from the ODA, okay, for his contributions to organized dentistry. He practices implant dentistry at Park Place Dental Center in Brampton. Beautiful, beautiful office. And he works with BioHorizon Canada, Aurum Group, and Microdent and Core 3D Milling Center to help make the reverse margin products available to dentists across North America. And he lectures nationally and internationally. He's in high demand. And today he's talking to us about comparing the efficacy of the chamfer margin and reverse margin systems and at preventing submarginal cement. Emil, it's all yours. You know, thank you again for accepting to present to our group. And I'm going to disappear by listening to the presentation. It's all yours. Thank you, Emil.
Thank you very much, Ettore. Well, welcome everybody to the Chamfer Margin Showdown, bringing a new standard of care to town. First question is, what's the standard of care? Well, the standard of care is a dynamic concept, and it's always the best we can do for our patients. And I have a patient that is at my practice. She's being treated for antibiotic-resistant infections. And she told her physician that she was going to have some implants done. And he said, don't get any more implants. He says, implants are a cesspool of infection. Now, that's a perspective of a colleague of ours, our physician. And I'm not sure that's the perspective we want to have. And the question is he right? Look at the open margins here, the subgingival cement, the implant abutment misfits, the abutment prosthesis misfits, non-accessibility to care, and look at the devastation, the disfiguring damage peri-implant disease makes and failure. So is he right? And I'm going to cover that. And from Dental Town, I picked up this picture from the internet. And quite frankly, Jepson et al., not so long ago, in 2015, came up with an article that says, well, we don't have any effective treatments for peri-implant disease, and we don't. And so, so, I guess our best solution is to try to prevent it. And certainly, the key to preventing anything is to understand its root cause. And so that I'm going to help you understand a little bit better. Murray Arlen is one of my heroes, and he collected the data for 30 years on all the implants placed, and he collected the survival rate. Well, we all have to understand what survival rate is because it pops up in the literature all the time. Survival rate means the implant is still in the mouth. It doesn't speak at all about peri-implant disease or the state of it or the happiness of the patient. It's just still in the mouth. And so the interesting thing about Murray's articles was that he placed and restored, well, his referring doctors restored over 15,000 implants. And we look at his data of survival. Well, the 8% failure rate over 8 years is fairly similar right across the whole border. In all the literature, they seem to come up with a very similar number to that. So the 10-year failure rate of an implant is about 10 years. And the interesting thing is that his group that he treated before 1999 had almost identical failure rates over the first 10 years as his group that he did 20 years later. So basically everything stayed the same over 30 years, despite, the amazing advancement in technology where they make the parts fit so well. And certainly we know that every implant company crows about how good their fits are, and they have a right to crow about it. But, somehow we're not taking advantage of that beautiful technology. Are we missing something? That's the question. So what do all these reviewers say? Murray Arlen did 15,000 implants. I'm sure these reviews are based on perhaps closer to 100,000 implants. And they all say basically the same thing. And when we look at the patient's experience rather than the implant level experience, we looked at 8% failure rate translate in that 14% of our patients have to deal with implant failure. That's not 8% anymore, it's 14% because they have more than one implant. And look at this, 20% of our patients have to deal with peri-implantitis. That's that massive bone destruction. And 47, that's half of them, mucositis, peri-implant mucositis. So that means 2/3 of our patients have to deal with a degenerative disease, disfiguring disease that is on its way to destroy the implants. And this disease requires extra treatment. It's not like we are supposed to watch it as the implant fails and there's no good treatment. So you can see how it would be very important if we could only prevent more of this disease. And the survival rate or failure rate is only the tip of the iceberg. And here's another thing. It's the same for cement in and screw in installation. So if you listen to the podium, everybody wants to screw stuff in, but they have the same complication rate, the same failure rate, the same peri-implant disease rate. But yet, usually the story is very one-sided, isn't it? So anyway, when the patient here has to deal with complications, it makes a whole cascade of liabilities all the way down the implant industry chain. It's not only that this patient will never refer her friends to you, but the dentist who referred her to you is probably going to have a second thought about referring more to you. And the dentist who did the treatment may want to change labs because they might think the lab screwed it up. And they may also change implant companies because they think, well, maybe the implant company is not doing a good job one way or the other. You see, so it stimulates a whole bad vibe all the way down our industry when the patient has to deal with stuff like this. Oral pathogens, bacteria, are the cause of peri-implant disease. The industry is in unison on that. There are some other things that may be making the problem worse, but it's generally an infection, right? So if we really, really want to improve the job we're doing for our patients and try to get a better, more predictable results with a lower failure rate and lower complication rate, we really do need to look at things at the microscopic level, don't we? Because that's where our enemy is. It's not macroscopic, it's microscopic. And if we look at it that way, this is a cross-section of a single hair that you can hardly see. And the cross-section can house 8,000 oral pathogens. And if we stuff that hair with like a sausage, each millimeter of that hair will be able to have 8 million oral pathogens. You see, it's a different place that we have to look at them from. And if we just wrap the one hair around a molar, we have like a quarter of a billion bacteria just there, one hair width, but this is like a 0.5 millimeter of cement space and overhang. Well, that has way over 1 billion bacteria. So that's the assault. That's the assault that these oral pathogens are causing to our patients. And we know that the expression of disease, and this is basic immunology, basic microbiology, you see, that the expression of the disease is a result of a balance between host resistance, the size of the inoculum, and the pathogen virility. And I'm not sure what we can do about pathogen virility, but perhaps we can reduce the size of inoculum so we don't challenge the host resistance so much. And I think, leaving areas in a peri-implant environment that the patient can't clean and our hygienists can't get at, and our dentists can't even drop a probe around, maybe that's not so good for the patient, you see? And the question is, are we relying too much on host resistance to make our stuff work? And that's it. And can we do something about it? So a great paper just came out by Heights and Heights in 2020 here. You see, just came out, and I really highly recommend that you look it up and read it, because I think it's right on the ball. And unlike a lot of the verbiage from the podium, they actually talk about stuff that interests me, because I'm interested in prosthesis-related problems. And why am I interested in that? Because it's where we can have the most effect, where the labs can do the best job, where we can do the best job in the mouth. You see, this is where we have most control. And we can't really control the history of perio, but you take a history of perio plus a non-cleanable prosthesis, and you have the highest risk. This patient has the highest risk of developing peri-implant disease. Never mind the other complications like broken screws and chipped porcelain. Never mind that. Just the biological part. And look what else they put in here. Excess subgingival cement. Yeah, and it doesn't matter really. This is for implants, but it's also effective on natural teeth. You leave cement under the gums, and we've been doing that for 100 years, by the way. It's going to cause perio problems besides the caries and endo. We don't have to worry about caries with the implants, but we still have to worry about the peri-implant disease. And we know there's no good treatment for it. And look at poor fit of the parts. Wow. Well, I hardly ever see that anymore. 20 years ago, when I was doing my research, the literature was just stuffed with poor fit of parts. And then all of a sudden it went quiet. It's like the industry just threw up their hands and said, well, we can't do anything about it. This is the best we can do. Same with the cement people. Oh, this is just the best we can do. Nobody bothered to find out what the cause of these things were and if we actually could do something about it. And that's it. So this is a very, very powerful paper, and it's a very good review. It's a big review about the subject. So, and their conclusion was a prosthesis should be cleanable. It should have optimally fitting parts. That means no implant abutment misfits, no abutment prostheses misfits, and without subgingival cement. And that way we can reduce peri-implant disease, which affects 1/3 of our implant patients. You see that? And so I think that's important. And you see, from a business point of view, if you reduce the complications, then it's easier for dentists and patients to accept to do more implants and get rid of those really crappy teeth that they're trying to save now. So it's good for the whole industry if we can reduce the complications. So what are the root causes of the plaque traps, the places the patient can't clean? Okay, like here, abutment prostheses misfit, implant abutment misfit. This here, open margin, subgingival cement, and overhangs. What's the cause of these things? Because, I've been going to lectures for a very long time. And every time I go, they talk about all these disjointed parts. Well, now I've discovered the root cause of these things. So now it's not disjointed anymore. If you understand the two root causes of the problem, then you can offer some solutions and try to prevent them. And that's my my idea. And what are the two root causes? Well, they're the two old dragons of dentistry. And these are the metaphors so you can remember easier. When somebody comes up with something you knew, you can think, well, I wonder how this deals with these two root causes of problems. And then you can decide whether you want to integrate or not. And they are the root causes of mechanical problems, okay? They cause the mechanical problems that predispose our patients to plaque traps, to biological complications, because they present a advantage to the bacteria, places to grow that the patient can't get rid of, you see? And that's how it works. And these are the two root causes right here. And it's so simple. It's only two of them, not 2,000, you see? And all the things that you're seeing, like loose and tight contacts, misfit implant parts, joint instability, poor prosthesis margins, hyperocclusion, subgingival cement, are all caused by these two root causes, which are called prosthesis dimensional error, and the tissue effects. They cause them all. And I've studied this extensively, and they cause them all. So that, to me, made my diagnosis of the problem a lot easier and helped me bring the solutions I'm going to present to you. Independently, prosthesis dimensional error and the tissue effects can cause all of the problems I just mentioned, each and every one of them. And so that's why I think it's been so tricky for the last 100 years to figure them out, because perhaps they started working on prosthesis dimensional error and they still seen the problem. It was confusing. And then some people might have thought of working on the tissue effects, but I did all the research on the tissue effects, and they still didn't solve the problem. So they gave up. They simply gave up and said, well, this is the best we can do. So our 2/3 of our patients have to suffer peri-implant disease. Together, it's very difficult, very, very difficult for the patient, together, it's very difficult for the dentist to deal with them. We have to separate them in order to deal with them, to make it possible. And with our making of the prostheses, there are just a lot of finicky steps, and each little step adds more error. Every step, right from adding the porcelain and polishing the contacts to making the model to adding all these parts. This printing machine needs to be cleaned all the time. These all have to be calibrated, and it's just a lot of steps. And in 2021, the acceptable error of just the model part is plus or minus 150 microns. Or we could call a 300 micron spread. You know how big bacteria are, like 1 micron, right? 1 micron. And they have flagella. They know how to swim around. And we're accepting building a prosthesis on a model that's plus or minus 150 microns. And 150 microns is damn accurate on the eye level, but on the microscopic level, no. And that's the problem. And that's why it's prosthesis dimensional error, why we have to, when we get the beautiful little product from our lab, that's why we have to have all this junk on our bracket table to adjust contacts, fit, and occlusion. Even for single crowns, contacts, fit, and occlusion, right? Because if everything was accurate, we wouldn't have to do any of these things. We just put it in. And we have good days and bad days, you see. That's the thing. And once we make the impression, or even nobody knows how accurate that particular model is going to be, because the only reference the lab has is the model, is your impression. And whether it's good or bad, and that's the only reference. And what reference do you have? Okay, you can take a good impression, but you don't know how accurate it is. You don't know what happened to it. You don't know whether the printer was gummed up a little bit that day, or what the milling machine was a little bit, the diamonds had come off it a little bit, so it wasn't really perfect anymore. So, and who thinks fit is really important? Who thinks that? Well, Health Canada and the FDA do. They think it's important. And in fact, they have ISO standards that the manufacturers have to meet if they want to sell their products in Canada and the United States. So they think it's important. And what they do is they take this, the implant, and they put it together according to manufacturer's directions, strike it 5 million times. If it falls apart, well, simulating 5 years of wear in the mouth, well, then it fails. So you can bet that these instructions tell the lab that's going to test them how to fit them together optimally. You see, that's for sure, because they want to sell their product. And what has this regulation done? Wow, the manufacturers can now produce parts and do routinely produce parts at plus or minus 5 microns. It's not 1 micron, 5 microns, plus or minus 5. That's a 10 micron spread. That is amazing, amazing. And this is what the implant companies crow about. Oh, look at how accurate these are. It would be a game changer if the dentists could only exploit the microscopic precision and ensure that they're able to put them together, like in the FDA test, to put them together optimally. But the problem is here. So what is missing from the Health Canada and FDA tests? Well, first thing that's missing, there's no mouth. There's no gingiva and adjacent teeth. There's no multiple retaining implants. There's no multiple unit prosthetics. You see, that's missing. Maybe it shouldn't be missing, but it's missing. Okay. And there's also what's missing. I've read through a number of manufacturers' directions. There are no manufacturer's directions that tell the dentist how to optimize the fit of implant parts and prevent subgingival cement. There's none of them that I can see. And if you think you found some, just send them to me. I'd love to read them and give you my opinion. So how can we work in the mouth microscopically? Logic. At least the process we use needs to be logical, able to optimize the fit. We may not strike gold every time, but at least if the process makes sense, then we have a chance to optimize the fit just like the FDA would like to have. That's what we need to use. And it's the highest power humans have, is their ability for logic. And dentists, they are troubleshooters and very intelligent, but don't be fooled by stuff you hear. Use your logic, and then everything will fall into place. So what happens now with the screw-in technique? Well, the lab puts the prosthesis together with the abutments by casting or cementing. It doesn't matter how they do it, but they put it together and they make it fit the implant analogs on the model. And we know the model has an accuracy of about that. And all the parts that are in there. There's a lot of things in this, plus or minus 150. So that's the best scenario. And now these connectors here are plus and minus 5 microns. You start to see the problem. The more accurate these are 30 times more accurate than this. So if they're held out of place, how do you expect them to go all the way in? Because the prosthesis dimensional error now will kick in and hold these things in a 3-dimensional wrong place. And now you're going to try to put them in the mouth. So I'll tell you the truth on this. Any multiple installation, like a 3-unit bridge or bigger than that, there's no way on this planet that you can optimize the fit of the implant abutment junction. Somewhere the error has to show up. It doesn't just disappear. It doesn't disappear if you stick your head down a hole and want to ignore it. And in this case, we were just lucky we could see it right here. So right off the hop, because of prosthesis dimensional error, it ain't going to go in. It's just not. Then in addition to that, we have to line it up with the path of insertion with other things and with 2 implants that are slightly off from each other, with the abutment screw channels, which are slightly off from each other. And so it just can't work. And then we're doing it all while we're trying to compress the gingiva underneath here by screwing it into place and displace the gingiva here when the gingiva is up against bone, where it gets very hard. So can we do it? Not this way. We cannot do it. Sorry, folks. I wish I could say otherwise, but we cannot do it. And it's even really hit and miss, even with single crowns. But I don't have a time to talk about that today. You'll have to get the longer version of my talk. But even with single crowns, it's really hit and miss. And so what happens then? Well, what happens, the bacteria get in here, you see, and with every bite, the bacteria, the endotoxins, the pus moves up and down in the peri-implant environment. So there we have our 67%, our 2/3 of our patients having to deal with this infective process, which is not good for them systemically either, when we could do a lot better here. So what happens? We get unstable joints, reservoir for oral pathogens. I wrote in Spectrum Implants in June, July. You can see my article. Actually, quite a few people have downloaded this article because I guess the title's a little sexy, you know. But the fact is, right now, misfit implant parts and poor margins are the standard of care. And I'd like to see our industry change that, because I think we can. And is anybody conflicted about this? I am. I'm conflicted about it. And it's open for free download at reversemargin.com. You can download all of my work there. I'm not the only one talking about this. This is Scott Fromm. Very nice paper, The Dreaded Macrogap, a page and a half. Bacteria, macrogap, peri-implantitis, mechanical failure, screw fracture. Who else is talking about it? Carl Misch put a whole chapter in either of his 2 books on this. And then there are many other articles about it. They say passive fit could not be achieved with screw and prosthetics. So you know what? I didn't do the research to discover this. There's ample research. So the people who want to say, oh, it doesn't matter or it doesn't exist, you're solving a problem that doesn't exist. Well, they just, you know, it doesn't exist for them because they just don't care. That's it. They think 67% of our patients should suffer the disease because they want to not care. And I don't think that's good. That's not dental care. That's something else. I'm not sure what it is. So here it is. So in addition to misfit connecting parts here and here, what else is the problem with the screw-in system? Well, now we got misfit parts. Why not just cantilever forward and back off them and really stress these joints? Okay. So that's the second thing. Now, wouldn't they work better if we could optimize the fits? When there was a time when we couldn't, then I think that becomes the standard of care. But we can do it now, and I don't know why we're not just doing it, you see. And what else? Well, the biggest thing that dentists bitch about is having to maintain these screw access holes. You see, this is a screwed in, this is a filling, you see the brown ring, and this is a cemented in, you see, and this plastic doesn't maintain the occlusion very well, and it's certainly not aesthetic, and is certainly high maintenance. So yeah, that's a problem, but that's not a game changer. It's just a nuisance, right? The nuisance is, but because it's ugly, we want to hide it in the back, and we have to make the cantilevers. That's not a nuisance. That's a big problem, you see. And now, more and more, especially with the All-in-X stuff, we're getting these big prosthetics where, I mean, can you drop a perio probe here? Like, really, can you drop a perio probe here? Can your hygienist clean in there? And some clinicians say, well, you know, I take them out every 6 months. Do you know how long it takes a bacterium to divide into 2? At 20 minutes. In an ideal condition like this, 20 minutes. So you're going to take it out every 20 minutes? You think every 6 months? Maybe you should make it more cleanable by the patient, and maybe then you wouldn't have so much liability. And so then, in addition to it, and I got to tell you that this makes me queasy. Like, look at all the bone, and look at, is there really that much disease here? To what inspired somebody to do this and be proud enough to put it on the internet? It makes me sick. It makes me sick. We shouldn't do that. And then, so they do this in order to get wider bone here. And then if one of these implants fail, one of these uncleanable implants, because they do this on top of it, fails, well, then the patient is out of luck, right? And if it's over after 5 years, maybe they got to pay for it themselves. And you know that patients can't detect peri-implant disease very well on their teeth, and they never had implants before. So they only start to detect it when big bags of pus get spewed out every time they bite, or if something really starts to be painful. So that's lulling our industry into feeling that's good. And look at where the implants are coming out on this type of a case. Look, you know how wide this prosthesis will have to be, and you think it's cleanable? It's not even close. Okay, and the cantilevers, and they can't even make the joints fit. I'm sorry, I'm an old guy, but this would not be passable. I think that would be good. And what happens when the peri-implant disease creeps up these great big zygoma implants? Oh my gosh, shouldn't we at least be able to optimize the fit of parts and provide access to care before we even consider doing this kind of aggressive behavior? This group here, Derrick's et al., 2,277 implants, almost 600 patients, said patients with 4 or more implants, patients with all on 4, retaining a prosthesis had 15 times the rate of peri-implantitis than patients with prosthetics with less than 4 implants. Wow. And they didn't even separate out the 3 implants, you see. But and I would say probably access to care is a big problem. Now, here's the thing. Immediate implant placement on multiple implants may require cross-arch stabilization. It may require that. And this temporary prosthesis here, I would say, because it's luted in the mouth, is probably close to passive, if not passive. And so, in fact, when we put this big hunk of teeth in the person's mouth, for 4 months, if they can't clean under there so well, I don't think it's a game changer. I think, in fact, we can do this during the temporization phase, but we shouldn't be chopping off a whole bunch of bone. And the industry is changing here. Mark Kwan, who's done 1,200 arches already of that nature, is changing his tune now, and he's not changing FP1s to FP3s for this purpose anymore, because he's already been bitten enough times. So we should change this whole thing. But anyway, the question is, do we still need cross-arch stabilization after the implants are integrated? So perhaps, I don't know, perhaps we need this during the first 4 months while the implants are integrating. But do we need cross-arch stabilization once the implants are integrated? And I would say no. So in this particular case, the design of the final prosthesis, the treatment plan, should have, 4 bridges here. If you're going to put 8 implants, why not? That's good. So when this implant fails here, we only have to deal with this part. In fact, we can chop it off here and we can just deal with this part. So it makes the consequences of failure, because we know what the failure rates are, it makes the consequences less. And that's important. That's what a good treatment plan does. So here I'm going to make a little proposal on how to fix the All-in-X, but I'm going to tell you in advance, I can't really fix it. There's too many things wrong with it. But I try to fix it because there's so many people trying to tend to do this treatment. And quite frankly, I think it's crap. I think it's crap the way it is now. And I'll show you why now. Fixing the All-in-X system by separating the installation of the implant from the prosthesis. That's the first thing we got to do, because we got to optimize the fit of parts. And it's so easy to do that. All the dentist has to do is put together the abutment onto the prosthesis and a prosthetic connector or gold cylinder or whatever you want to call it in the mouth at the time, you see, and without the prosthesis attached, because usually the lab puts this into the prosthesis on the model, which has that error. But we can put this in the mouth, and now we've optimized the fit of all these parts, and they said it couldn't be done. It's so easy, okay? So, and the dentist can put a little Teflon here so the screw axis hole doesn't get So we've done the first thing just in one little step. So once you understand the problem, it's easy to fix. Now, the second thing is, now the prosthesis, this is a cross-section of the prosthesis with the screw access hole full of acrylic, okay? So now the lab produces the prosthesis with abundant cement space here, and the dentist can put it in and out of the mouth, and adjust, the tissue interface and make sure it doesn't bind. And then when it fits, put it together and cement it in the mouth, okay? They can cement it in. All of a sudden, whoa, look at Carl Misch and all the rest of the gang said you couldn't do it. Now we have a passive fit. So now we can unscrew it and we can refine the surface, make it real pretty. And now we can screw this back in. And now we've done it. So at least we've done the first thing. We've optimized the fit of all the parts and it would pass FDA tests. That is good because that's the spirit of it. Now we're taking advantage of what we have to work with. And we did it the Svoboda way because nobody ever published on that. And it's so easy. But that's not the only problem. This access to care, these wide prosthetics. You see, this is how it's delivered from the lab with these prosthetic connectors already in. See, that doesn't work. You have prosthesis dimensional error then. And so these wide things, nobody can clean them. They look real pretty. They're really artistic, but they're no good. They're no good. So if we can, there's a couple of choices here. We can use temporary cement in the front and keep it as one unit if that's what you want. And these back screw access holes will hold the front in. That the cement just occludes the space. The cement has two purposes, occluding the space and retaining the prosthesis, you see? And we can use Tempon. It comes apart real easy. I did the experiments, okay? But if we really want to do a good job, besides, and look at the narrowness of this prosthesis now. It's not like this. It's really narrow because, number one, we kept the ridge. We didn't chop it down. And number two, we have a narrow profile for access to care. And that's it. But if you really want to get good, let's just segment the final prosthesis, not the temporary, the final prosthesis. And now it's accessible to care. Now, isn't that a lot easier? Doesn't that make sense to you? But there's yet another problem. And that's why I said I couldn't fix it. I tried. But the other problem is, besides the accuracy of the parts that the industry is able to do, and I really got to say the amazing accuracy, they've done such a good job. And by the way, they can't make it any more accurate. Otherwise, we wouldn't get it in with the old system of installation. But with the way I'm proposing, they can make it more accurate because my system allows even a better accuracy if it comes along. The old system, you couldn't even get it in. And yeah, okay, let's stop there. I don't have enough time for that. But anyway, look at the last thing that I can't fix is that All on X relies on stock parts. Here we have technology that allows us to do site-specific patient and site-specific parts, customized. And we're not using that feature. We're trying to buy these cheap stock parts which have a limited heights of tissue collars and angles. And have you ever seen gingiva that went straight across here like this? So we have to make so many compromises. So even if we want to pick this up in the mouth, it's still not as good as if we would use custom abutments to control the outcome by controlling the height of where the gingiva is going to be, the margin to the gingiva. We can control the material we use. We don't have to use this ugly gray stuff. We have zirconia, which is very biocompatible. So if we want to take advantage of the site-specific custom abutments in addition to the accuracy, we got to get with the modern times. We can't get stuck with stock parts, and I can't fix that. And so this case was going to be an all-on 6 for my experiment, but we just changed it into what I would do every day. We got now three bridges, and this patient is going to have a beautiful result. And if we have problems in the future, we have to only deal with one bridge. And you see, we take advantage of this part here, which is the very highly precise manufactured part. Neodent, by Straumann, by Noble Biocare, they're all making really, really good stuff. But we got to take advantage of it. And if we start here or here, we can customize the shape of the part, whether we want to make it all solid titanium or whether we want a hybrid. And look at how beautiful it is. And guess what? That actually already exists, except for the design, for the cementing system. The only problem, there are two problems with the cementing system. We'll get to them, okay? But with the cementing system, the parts are always put in individually. So we could optimize, we have a chance to optimize the fit of the parts. If it doesn't go down very well, we can open the gum a little bit and make it seat. We can develop the tissue portal, the trans tissue portal, and look at what we can do. We put this in all first, it's so beautiful, and then we put the prosthesis on it. And there's no prosthesis dimensional error in that step. We've separated the dragons of dentistry. We've separated the root causes of problems. So here's my experiment now, the Chamfer Margin Showdown. And so here's the Chamfer Margin. It's one of the most used, margins in the world. Okay. And then the feather margin, I think, is even worse in this department. And the butt margin is not much better. Okay. So this chamfer is in between the two, and it shows. And here's my reverse margin. And you can see the beautiful contours of the chamfer margin. Looks good. Doesn't work. You see? And this looks a little stranger, but it's made to work. You see, that's the difference. So let's see the experiment. So here we go. Here's the chamfer. Notice the abutment is narrower than the crown. Notice here the abutment actually is wider than this part of the crown, that little indent. That's important. Okay. So here we got the reverse margin abutments. Here they are in the mouth. You see all the funny business that doesn't look so funny when it's in here. It looks very normal. And here you can see the top of the abutment right between the gums, because that's where the cement comes out. And that's how it works. So what is the experiment? Okay, we took a bunch of crowns, and the nice thing, we could use CAD/CAM technology. So they're all the same, you see, or very similar to each other. And so we cemented at the average cementation force, which is about 4 kilograms. We used a temporary cement. And after it started to harden, we put the clamp on it to hold it. So I didn't have to hold it for 5 minutes. And then I took pictures of everything, and on my publisher program, I measured how far the cement went past the margin. That's what's important to clinicians. How far did it go past? I don't understand the research in this area. Why do you look at area of cement that went past? It doesn't tell us how far it went past. Is it within reach or out of reach? That's what's important, okay? So that's why I use that study. And my study is unique in this area. So what's the result? So what the result is, the chamfer margin, the cement went an average of 1.8 millimeters past the margin. Now, when you have a margin that's 1 millimeter, so it's almost 3 millimeters below the gum. You see that's on average. And the range was 0 to 7 millimeters when Dr. Majid Sakari did it. Okay. And I got to tell you, he just pressed a little harder than I did. I was watching his measurements, and they were about 4.5 kilograms. But mine was about 4 kilograms, but I've been doing this for a long time, and my results were almost identical. However, when we looked at the reverse margin, the average was 0.1 millimeter past the margin on average, but the range was 0 to 0.6. So, at 1 millimeter, that's a millimeter 0.6 under the gingiva. 0.6 is not ideal. Okay, I would like to make that better. And when I did it, it's almost identical, but we had a lot more zeros, just at, half a kilogram less. We had a lot more zeros, and my range was, there was only 2 of them that went past. It was, and they went as far as 0.5 past. So again, it's really a lot better than the chamfer margin. But clinically, we'd like to have this a lot closer to 0, wouldn't we? But you can see the big difference. And then with Dr. Anand Sharma, I did another experiment with the same group of things, and I did chamfer margin and reverse margin with 2 kilograms of pressure. So I reduced the pressure. Now, I got to tell you that the chamfer margin, the reverse margin is built for low pressure. The chamfer margin definitely is not. So I can go a lot lower than 2 kilograms. In fact, that's going to be in my next experiment. But already here at 2 kilograms of pressure, the average was way better for the chamfer margin, but still the range was 0 to 3.3 millimeters past. So it's a fail, you see. But look at this. With the reverse margin at 2 kilograms of pressure and even up to 1 millimeter under the gum, we had 2 that breached the margin, and that was 0.1 and 0.2. Wow. Wow. Now that's clinically acceptable, and you can clean that off. So there we go. So reduced force was even better, but in any case, the reverse margin won. Now, I did a collaboration study with Thomas Linkevicius. Very smart guy, I got to tell you. So he agreed to do a collaboration with me, but I had no effect on the way he did the results. I was not involved in that, and I was a little disappointed in that, I got to tell you, because he decided to do the easy way, which was yes, no. So we all know what no means. No means no cement past the margin. But what does yes mean? Does yes mean 7 millimeters past the margin, 3.3 past the margin, or 0.1 and 0.2 past the margin? You see, that additional information would have been really useful, and he didn't provide that. And anyway, nonetheless, this is a clinical study. He found that the reverse margin had 3 or over 3 times more no cements than the chamfer margin. So it won in any case. And when I look and compare my in vitro study with his in vivo study, his results look a lot like my 4 kilogram pressure study. You see, this is Svoboda, this is Linkevicius. And when we take it down to 2 kilogram and did the yes, no, the reverse margin was 6.6 times better than the chamfer margin. So guess who won first place? It was the reverse margin, yeah, by far, by far. So that begs the question, you know, in spite of the fact that the chamfer margin and feather margin and butt margin, they kind of look cuter and what we learned in dental school, they don't work. They don't work at preventing cement, subgingival, and even prosthodontists in the university setting couldn't prevent cement. But the reverse margin can. It can help you, the general dentist and the specialist, prevent subgingival cement. It looks a little different, but that's because it works different, you see? And there you go. So we know who the winner is. And in numbers, look at the lower pressure, even 1 millimeter margins are safe and easily accessible for you to do this thing. Because you see, intra-oral cementation is the key to making things passive, to fill in the space between the mechanical deficiencies that are in the production of crowns and bridges. So that's why that works this way. And now, how does it work? How does it work? You know, quite often you read a paper or from the podium they say, oh, don't use stock abutments. Don't use this. Don't do that. Don't do that. But they don't tell us why. And if they told us why, then we could use this and we could extrapolate from it. But if they just tell us don't do it, like we're not idiots, right? So if they just tell us don't do it, we can believe it or not believe it, or say they're either full of bull or not. But if they tell us why, now we have another handle with which to work, to judge what they said. So I'm going to tell you how it works. Well, there are 2 tissue effects, and they're kind of the same, but kind of different. And I can tell you, the first one I discovered was the gingival effects, and the gingival effects cause a ton of subgingival cement, the gingival effects. And I wrote a book on terminology. Please go to my reversemargin.com website and read it. It already has had over 300 downloads, and it's important. You see, not only did I have to find and create the software and hardware to be able to make the reverse margin, I also had to develop a language to discuss things. When you make something that's truly new, the language doesn't even exist. And I didn't even realize that. And so I wrote this terminology paper. You know, just like computers, they didn't have words for the computer stuff until later. And so some of those words had to change, and some of the words have to change in terminology too. So at least you can talk to your friends about the gingival effects and resistance to displacement and prosthesis dimensional error. And so it's got to be in your vocabulary. Otherwise, it's not in your brain. And that's where it has to be if you want to get to the next level. So resistance to displacement and gingival effects are the two tissue effects, and we have to address both of them. And as you see from the design of the reverse margin, not only do we have a bigger cement space, which facilitates low pressure cementation, even for single crowns, but we also have something that redirects the cement out of the tissue space, and we have an indent that allows that to happen and keeps this crown from touching the gingiva, and so we don't have any tissue effects. You see, that's how we prevent both of those tissue effects, resistance to displacement and the gingival effects. And so cementation is a hydraulic event. So the cement comes down, it wants to go somewhere. If we let it out, it goes out. And this is really easy to clean off clinically. The chamfer margin, on the other hand, and the feather margin and things like this, where the abutment is narrower than this profile here, well, the crown, as you're putting it in, it interacts with the gingiva. The gingiva gives resistance, and so it makes a seal here during your cementation process and doesn't let the cement get out anywhere. And that's why it goes under the gum, you see? And this 45 microns of cement space is insufficient to deal with prosthesis dimensional error. And because it's supposed to touch here, a slightest lateral movement will make this thing rise up this thing and give you an open margin and an overhanging margin on the other side. You see how that works? Anyway, so the chamfer has to deal with the tissue effects. The reverse margin doesn't, and that's why it's better. And these are diagrams. They're exaggerations to show you how it works. So here we have the reverse margin abutment, and you can see the cement space, and you can see the portal, how the cement can come out of here, and how the gingiva never touches the crown. So when you try, once the abutment is in, the crown doesn't touch the gingiva. Hey, no more bleeding during the cementation process. Access to the top of this ledge, you can feel it. So easy, okay? Meanwhile here with this guy, the crown interacts with the gingiva. You get bleeding. Then it presses against it and makes the seal. While you're cementing, the cement goes a little bit up and a little bit down. And that's the problem. So you got to push hard like a dog to push it and make sure to reduce the cement space at the margin. So you push harder. Here you don't have to push, because it doesn't matter if it ends up being a little higher or lower. You don't have any more open margins. You don't have any more overhanging margins. This passes the deal. This is how it works. And this is the consequence. Chamfer margin, reverse margin. You know, it's a no-brainer. Once you understand, it's a no-brainer. And once you understand, you can never go back. That's really what it is. Yeah, and knowledge changes you forever. Knowledge with a desire to become better. Not accepting the status quo just because it's the status quo. The thinking man has to accept the new knowledge and react on it, not just sit there and watch the barn burn down and pretend that they're doing a good job. We have to make these changes. We have great labs and great manufacturers that can help us, but we, the dentists, are responsible for making that move, because if there's no demand, they can't go there. They have to make payroll every week as well, you know. But we can make this change and make a big difference for our patients. And we did TIA, we did a workshop, and here's your chamfer margin, all fail, and here's reverse margin, all successful. And we had way over 20 dentists participating. And I did clinical studies as well. Cement never breached this margin in my clinical studies. No more subgingival cement, no more open margins. See, once you discover what causes it, it's easy to prevent. But, you know, I had to stop placing implants and being so busy with my clinical stuff. I instead went and did the research, and that took a lot of my time, you see, but I felt passionate about it because I wanted to make a difference that will help my colleagues, but help my patients too, you see. And so in conclusion, this is Majid Sakari. He's now in a prostate program at U of T. And this is Anit Sharma, my very good friend and a very skillful surgeon in my office. And we can say in conclusion that the reverse margin system outperformed the chamfer margin totally. And this applies, you know, also to natural teeth. It's a little bit of a modification, but, you know, we place 10 times more crowns and bridges on natural teeth than implants. And the principles apply to natural teeth. And if we have time, we'll talk about it another time. Now, also we can install unreduced pressure with the reverse margin. We can't with the other because we're fighting gingiva and fighting contacts and not wanting bleeding, and it's just too complicated. Once we get to cradle the crown within the abutment margin space and we're not fighting the gingiva, we can go low pressure, and you know, the bigger cement space, we can modify it. So for a single crown, I use 80 microns, but for a bridge, we use 100 microns. And you know, the gingiva never sees the space underneath it. You know, it's on top. And we keep them as shallow as we can, between 0.5 millimeter and 1 millimeter subgingival. This system works very well. And unlike the chamfer margin, the reverse margin is built for low pressure. Now, we've talked about the tissue effects. And remember, you always got to be thinking about both the dragons. You know, the prosthesis dimensional error also can cause all the problems of the tissue effects. So let's see how we are dealing with PDE, or the prosthesis dimensional error. And both of these are over 100-year problem. And you know, the old dentist used to put these gold crowns in and look at it. Look, you know, a chamfer margin has a thickness, 100 microns, 200 microns. It's an overhang, you see? And it's exposed downwards, and nobody can clean under this overhang. And then when it's not adapted, here we have a caries growing there. And that's still so today, you see? That's what it is. But when you do things in the mouth, you have the best chance, because the mouth is the most accurate representation of itself. And did you know all the dental labs and milling companies, they put additional cement space to make it easier for dentists to install the prosthetics? Because if they don't do that, they lose customers and they have to do too many remakes. So that's why they do it. They have to find the sweet spot where they just put enough cement space so it'll go in and you won't detect the overhang, because we have to think microscopically, you see, so we don't always see it. And they know we don't want to put the probe down there and feel the margin in the mouth, because it causes bleeding, which adds another element to our problem, right? And yeah, so yes, you can put your probe down there, but you're going to cause bleeding. And it might be difficult, makes it more difficult for you. So you see, a lot of people don't do it. So what we have, if we use feather chamfer or butt margins and we increase cement space, what we do, we basically increase the overhangs. So if we increase the cement space, we're more likely to get overextended margins and overhangs. If we make it smaller, then we're going to get hung up and where the cement's not going to get out. So we're going to have open margins. And if the dimensions are wrong, like this one, say, is a little bit too big, well, these guys are binding here, you see, and again, we can get open margins here. So that's what prosthesis dimensional error does when we want to install it in the mouth. It doesn't matter whether we put on the chamfer margin, and it's even worse with on stock abutments, which the industry is trying to push us away from those. But because a lot of dentists don't understand why they should move away from stock abutments, that they don't understand that by taking all the emergence profile from the crown, they increase resistance to displacement and the gingival effects. You see, with a custom abutment, they reduce those elements, but the design unfortunately does not redirect the cement, and the design does not prevent the crown from touching the gingiva. So that's it. And so by increasing the cement space with all of these systems, we get poor contacts, hyperocclusion, submarginal cement, open overhanging, and overextended margins. That's what we have to deal with, and the patient has to suffer, you see? And you see how that works, don't you? Okay, so now here's two diagrams. And here what we're going to do, we're going to make a tight contact on this side, okay, on this side. So it pushes the crown over. Well, the reverse margin, we can push it over 80, a single crown over 80 microns. It'll make no difference because it's self-centering, and this will fill in with your resin cement or temporary cement, whatever you want to do. So, but if we take the chamfer margin and we push it over with that same tight contact, and do you think that you can adjust a contact at plus or minus 5 microns? Yeah, maybe in your dreams, but you're not able to do that. 5 microns is so little. I mean, you can hardly see my hair when I'm holding it, and it's 80 to 100 microns, you see? So you ain't going to do that. It's your dream world. So it's really good to have a design that is a bit self-centering. So if you don't get it right, it still is a perfect installation. And so here is the margin on both sides. You see the cement on both sides, and that's the key to prosthesis dimensional error. And so we're going to go through just a couple of little samples. So this is the trans tissue portal. Again, a new terminology, trans tissue portal rather than transmucosal, which is probably taken from the pharmaceutical industry. But there's many tissues in here, bone, soft tissues, keratinized, non. So trans tissue portal, we develop it with wider or custom healing abutments. And when we do that, that makes the next step easier. So now the closer it is to the shape of the reverse margin here, or whatever abutment you want to use, it just makes that installation a lot easier. So we can now overcome resistance to displacement and take care of the tissue effects. And that's how it looks. Beautiful. A little bit of blanching. And you know how easy it is to rinse and dry this off? There's no fluids around the cementation here anymore. It's so easy. And then it's so easy. Now we can try our crown in as many times as we want. We'll have no bleeding because the crown doesn't touch. And you can see the top of the abutment here, and we cement it in. And it's optional. You can put a screw access hole here. I never do because if I ever need it, I'll just drill a hole, and it takes me about 3 minutes, and then I'll have one of those ugly, high maintenance, plastic covered screw access holes. It's so easy to do. But the funny thing is, when you optimize the fit or the implant abutment junction, you rarely have loose screws. You see, when you do it the other way, you have lots of loose screws, and you think, thank God I had this ugly, high maintenance screw access hole. Look at how many times I got to go in and do it. Well, just optimize the fit, double torque, and you won't have to go in so much. Make your life a lot easier. And it's so easy. You see, here we developed the trans tissue portal. We put this in, excess cement so we don't have cement voids at your margin. And rubber stays so easy to clean off. And here's how it looks in the mouth, and very beautiful and easy to maintain. This area is easy to maintain by the patient with a gum interdental stimulator, a proxy brush, and a brush. It's so easy. Beautiful what we can do today. Look at how beautiful this lady is, and the crap that she had there that fell apart just rotted out. Why did it rot out? Because she has no access here, and the bacteria stayed under here and washed out the cement maybe, and look at the crap she had beside the teeth we're doing. And look at what we're able to do. A little bit of LPRF, immediate placement, zirconia instead of titanium, so it looks pretty. Here we put a crown, and here you can see the reverse margin abutment. A couple of weeks later, it's disappeared, and easy to clean. When you make your patients happy, it's really good for business. And this patient has been happy for 22 years. You know, not every time you leave cement do you get the problem. And that's the thing, you know. I think a lot of clinicians get fooled by some of the cases. Like, and anyway, so yeah, I just had the other day a discussion that I had a discussion that implants, that gold crowns were really, really good because some of them lasted for 30 years. Yeah, some of them did last for 30 years, but a lot of them didn't. Okay, so it's a lot of them that we have to look at, and it's the few that do is what you usually see during your presentations. And I think when the industry moved from away from intra-oral cementation because they didn't know how to do it safely, they kind of threw the baby out with the bathwater. They threw the important thing out with the bathwater, the key to even making screw-in stuff better. And I think that's my conclusion from my research. And the reverse margin system enables dentists finally to install things that would put a smile on the FDA approval sites, and the great implant companies will be finally happy that dentists can actually optimize the fit of their parts that they spend so much money making as accurate as they do. And I think it reduces dentist liability, because I can tell you, if I were a lawyer and you couldn't tell me how you optimized the fit of parts and how you prevented subgingival cement and overhanging margins, I would trounce you, because then the patient didn't have a chance to maintain it. And if the patient doesn't have a chance to maintain it, who's liable? You're liable. You see? So if you can tell the judge how you done it, and then you're not liable. Then it's the patient's liable. You understand? It's so important for us, for our industry. I don't know where it's going to fall, but I think, according to the Wilson paper, if I extrapolate from his work, then we could reduce peri-implant disease by about 60%. And that's not even counting the reduction in overhanging and open margins. So I think even 10% would be amazing. Amazing. You know, there are like 13 million implants placed every year. It'd be amazing, but 60%, come on. We got to go towards that target, because we can do it. It's easy to do. I spent the last 7 years figuring it out, you see? And so you have to make that healthier choice and choose the reverse margin system and usher in the new standard of care. I've already established a new standard of care because my patients all got this, and they all got it for a very long time. So if I can do it, you can do it. It's revolutionary, this design, because it's been well thought out. And it's even better than my initial ideas were, because it took me all this time really to understand the implications of what we're doing. James Miller from Oregon, 2 years ago, the last time Annette and I, this is Annette and James Miller in Las Vegas, we're at a table presentation. We won a second prize for our voids, you know, leaving cement voids at the margin table presentation. We won second prize, only beat by Loma Linda with a great big team. And but anyway, he's done over 2,000 of them 2 years ago. And he said, Emil, the reverse margin design changed my life. And I was a bit embarrassed in the beginning when he told me, but you know what? I realized it changed my life too, because I hated the installation part, because I felt out of control. I couldn't see what I was doing, push like hell, swell like hell. And then you take the x-ray and you got an open margin, you see? But that's all done. And this is Marina, our designer at Diamond Dental Studio. And that's where we design all the stuff. And Andy Summer from Microdent, he jumped all over this project because he understands it. He doesn't want to do all kinds of remakes. Remakes gobble up. You know, the margins are thin for these labs. They don't want to spend all the time sending drivers back and forth because you can't get the darn thing down because you don't know what you're doing. But he understands by building a little tolerance into the prosthetic system, and it makes it easier for everybody and less remakes. So it's more efficient. And Orem Labs, which are across North America, and Core 3D, milling institutions or milling companies, they have 3 of them, 2 in the States and 1 in Canada, in Calgary. They jumped all over it because they understand. But the thing is this, if they don't get the business, they can't be so excited about it, because if the dentists don't want to make the move, there's no demand. You see, they have to make payroll every week. You got to get it. So we got to want to demand it. Why? Because we want to do better. We want to do a better job for our patients. That's why. Okay? And Ettore already spoke that Murray Arlen has nominated me to take over the new host position for tackling those big questions. And I have at least 4 papers I want to put out there that you can read and we can discuss like a book club, you know, because I think these are key papers that kind of can screw up our mind, take us down the wrong path, and they don't meet the logical arguments. You know, my supervisor, Dr. Don Brunette, he's a cell biologist, but he wrote the book on logic, and he screwed up my mind, you know. So it's got to take a train of logic. And when I see some of these articles, I have to scratch my head how they could even pass the peer review. So I'm not sure what's going on, but you know, a conclusion has to be based on evidence that's in a paper, and so a lot of times that's missing. And sometimes they overstate the implications of the results and hide the details that would not allow you to make those jumps. So we're going to talk about that, and of course, I'm happy to answer any of the questions you might have on implantology. I've been placing and restoring implants for almost 30 years, yeah? Okay, so prevention is the best. Thank you for your attention. The reverse margin won first prize. It beat the hell out of the chamfer margin, and I'm just wondering what the logic is to continue using it, the chamfer margin and feather, because it's going to cause all of these problems. We can't get out of the loop if we don't make a change. Resources, all my papers are pretty well. They'll be in Spectrum Implants and at reversemargin.com. You can download them for free. And if you have any questions, there's my email address. It's email@dresvoboda.com. And now I can have a few questions. We have about 5 minutes to spare. Thank you.
Emil, fantastic. There's a lot of congratulatory messages on the chat, which is very good. I think your passion and knowledge comes through. I like that Svoboda way. I think that's the first time I picked it up, Emil. But I will bring you back because I want to hear more about the improved accuracy. You know, like you said, you know, it will take a lot of time. But let's go to the question. One is a comment, and it's coming from Dr. Gom, Dr. Larry Gom. And I guess he's looking for your humble comment, which we have other questions, so we have to keep it short. What Larry says is this: I agree with your theory that one of the contributing factors for peri-implantitis is the excessive amount of cement forced onto the gingival tissues when a crown is seated on an implant. Okay. However, I am also of the opinion that there are many other factors, which you mentioned when you showed the history of perio there, Emil. So he goes, I'm also the opinion, okay, other factors that can cause implant to develop peri-implantitis and fail. I think one of the most significant factor might be the lack of experience and expertise and surgical capabilities of the dentist who places the implant. And herein might cause the greatest reason for failure, which might unfortunately not be solved by the reverse margin. I humbly ask for your comments. Dr. Larry Gom.
Dr. Gom, thank you for listening to my talk. I'm humbled by you actually being there. I did take your course years ago, and it really did help me become a better surgeon. And thank you very much. Yes, there are a lot of things that can cause problems for our patients, including experience. However, we got to go to the things we can do. So my feeling is that if we can make prosthesis installation easier and at the same time optimize the fit of joints and prevent overhanging margins and implant abutment misfits and abutment prosthesis misfits, if we do that, that makes everything better. Everything better. Everything gets better by that. So less experience. See, once the miracle of implant placement and integration has occurred, What we don't want to happen is we don't want it screwed up by a bad prosthesis. And that's what's happening now. And there are patient factors. There are, history of perio disease. There are people who just drink too much, smoke too much, who have diabetes and don't clean their teeth. We know all these things, but everything gets worse when we don't do what we can do better. And that is taking care of those problems that I've presented today. Thank you, Larry.
There's another question, Emil, coming from Dr. Hani Shinuda. He said, based on this presentation, then using one-piece implant also would have a much better success rate, as there will be a lot less part discrepancies in terms of microscopic microns.
Yes, I'm just trying to think of the name of, the Straumann one-piece implant. It's hard to look back to an implant that, they had some surface issues. So it's not just one thing that causes the problem. However, the one-piece implant, you lose control of your margin gingival interface, because gingiva aren't generally straight across. And the downward facing margin, for example, on that, I call it the flower plot implant. The problem with that is that it's flat and it pinches tissues and it directs cement into the subgingival environment. And often it's placed in the subgingival environment because we want to hide the titanium. So theoretically, there are probably a few places where it actually works out really good. Practically speaking, it's usually placed in the subgingival environment to take care of the problems I just said. And the margin sucks. It's not very good. My margin is much better than that. So yeah, so the one piece, Schroeder was the one who invented the one piece. It was Dr. Straumann and Schroeder made the one piece, but he said, why have a connection under the gum at all? And I think it was genius. And so I did place that implant for about 5 or 6 years, but then it soon became apparent to me those problems that I just mentioned were real problems. Thank you for the question.
What happens when the abutment gets loose with a very tight cemented crown? And this comes from Dr. Khalifa.
Well, you can get your lab to mark where the screw access hole is supposed to be. And you just take a round, really coarse burr, and you just go down into it, or with a round-ended burr, and it takes about 3 minutes to drill through the top of that zirconia crown and dig out your Teflon and tighten the screw or change the screw. So you don't always have to take the crown off, so that's what it is. Or you can ask your lab to fill it up with plastic for you, and then you can deal with the problems related to screw access hole. So in fact, the other option is, James Miller in Oregon, he does everything with temporary cement, and he knows how to get them off, and it doesn't have problem. I don't do it that way, but so he uses temporary cement. So in addition to removing the crown, he uses temporary cement to make that part retrievable. And there's one point I was going to make as well, but it's kind of escaped my mind. I'll think what was the next question.
Okay, guys, we're gonna leave it at that because we're running. We're gonna run late on the other presentation, but again, we have a lot of congratulatory messages. Dr. Gom just replied to Emil, says, an excellent presentation. You are a credit to our profession. Larry Gom.
Thank you very much, Dr. Gom.
So
really nice.
I thank you very much, Emil. If you guys have additional questions, you see the emails at the bottom. If you have questions for the new program, the new feature that is going to run in Spectrum implants, you can ask him to, and he will reply and he'll get you involved. I want you guys to get involved.